Hi all, I am here with my new video on chapter Energy and Chemical Reactions. Let's start. In this video, we are going to learn about laws of thermodynamics. The first law of thermodynamics relates internal energy, heat and work. It is represented by the following equation. Del E is equal to Q plus W. This equation tells us that the change in internal energy of a system is equal to the sum of heat absorbed by the system and the work done on the system. In this situation, the heat and work are expressed as positive numbers. If heat is released by the system, and the work done by the system, these two quantities will be negative numbers. The first law of thermodynamics expresses the law of conservation of energy. If a system gains or loses a given amount of energy, then the energy gained or lost by the surroundings must be exactly the same amount, means the energy of the universe is always constant. Del E system plus del E surroundings equal to del E universe equal to 0. When a reaction occurs in a sealed container so that the volume is constant, the heat transferred under these conditions QV is equal to the internal energy change. Del E is equal to QV. If heat is absorbed by the system at constant volume, the internal energy will increase, means del E is greater than 0. If heat is released by the system at constant volume, the internal energy will decrease, means del E is lesser than 0. In laboratory conditions, most reactions take place in an open container at nearly constant temperature. So the heat transfer is equal to, in this condition, Qp is equal to a change in quantity that is closely related to internal energy and is known as enthalpy. The equation relating an enthalpy change to the heat transferred is del H equal to Qp. If heat is absorbed by the system at constant pressure, the enthalpy will increase, means del H is greater than 0. If heat is released by the system at constant pressure, the enthalpy will decrease, means del H is less than 0. The second law of thermodynamics. This rule governs the role of entropy in spontaneous process. According to the second law of thermodynamics, in any spontaneous process, the total entropy of the system and its surrounding, or the entropy of the universe, must always increase. This law is represented by the equation as following. Del S system plus del S surroundings equal to del S universe is greater than 0. Entropy is not conserved in a spontaneous process. Consequences of the second law of thermodynamics. One consequence of this law is that it gives assurance that the heat will flow from hotter objects to cooler one. It allows some spontaneous process to occur even when the entropy decreases in the system. For example, when water freezes at minus 10 degrees Celsius, the entropy of the system decreases as solid is formed, but the entropy of the surroundings increases to a greater extent, so the total entropy of universe increases. In our next video, we are going to learn about Gibbs free energy and standard heat of formation. Please like and subscribe to watch my new videos. Bye bye for now and thanks for watching my videos.